How are you, everybody who is watching this fantastic video? My name is Olenjolai from beautiful country, United Republic of Tanzania, and I'm very happy to welcome you today into our session 6 of coordinate geometry. So let's take this opportunity to welcome you first of all, whether you're a national or international viewer, you're warmly welcome into our online school that's called Tanzania Online Advanced Secondary School in square bracket Olenjolai. Simultaneously, I would like to welcome you to one of our YouTube channels at called Tanzania Online, a level 6 school in square bracket Olenjolai. Well, so we have so many things that we've prepared for you that we've been giving you a little introductions before we begin our sessions. And right now, we are very happy to also to give you a brief introductions before we keep on with the material that we prepared for you today. I remind you the assignment that you have, or just like assignment which which it's a vision for Tanzania Online Advanced Secondary School, is remember that we are here in order to teach, train, incubate, mentor, lead, and even encourage some group of students who are in advanced level, who will be ready to extract knowledge and wisdom from the classroom, formal and informal educations in mathematics and science subjects, and combine that knowledge and wisdoms with the knowledge and wisdoms of the Word of God that written in the Holy Bible in order to solve real life problems. So remember that the main objective of Tanzania Online Advanced Secondary School is to see our students when they are still in advanced level or after they graduate, they are solving real life problems. So that is our main objective. We have also so many specific objectives. One of the specific objectives like to make all our students to love advanced mathematics, to love advanced physics, to love basic applied mathematics, to love advanced chemistry. But we have another specific objective that we like to help all our students in continuous assessments, meaning that we like to prepare you for the midterm test of September, and also the terminal exams of December in Tanzania, and even also the second midterm testing of March. And then we prepare you also for the annual exams, pre-mock exams, for mock exams, for all the future exams that you are going to encounter in advanced level. So you should not worry about them. So we are going to prepare you step to step. It's a process. Actually, it's a long journey to cover advanced mathematics, but we are ready to take you from one step to another step. Again, we like just to let you know that for you, this is session 6. We are going to have more than 10 sessions, more than 20 sessions, almost 20 sessions or more, 20 sessions of coordinate geometry 1. So this is just a session number 6. In case that you want to get notifications and official notification after once we add a new video into our YouTube channel, then we ask you that to right now, before you forget, to press this button of subscribe. And then once you press this button of subscribe, then then we'll see a bell like this one, and then we'll go to the options of all. Okay, so a bell like that one, and then we have options of all, so that you get notifications once we add any new video. Okay, that's the point that we want to remind you. And then another point, another thing that we like just to let you know, that we like to ask, we like to inform you also about our online advanced library, our online advanced library, which actually that we're equipping our students with relevant materials, essential materials and books for them to go through the concept that we are teaching and even beyond of what we are teaching them. The first weapons is the syllabus. This syllabus is called the Advanced Mathematics Syllabus for Advanced Secondary Educations from 5 through Form 6. It's my research when I've been teaching advanced mathematics for more than 5 years in almost 6 regions of Tanzania, because we use the curriculums of Tanzania. Many students have been asking me questions where we can get these reference materials. So that's why that we are informing you. We are doing this business. We are just providing service. So actually that you can order this original copy of the syllabus of advanced mathematics for advanced secondary educations Form 5 through Form 60 for Tanzanian syllabus, and you can order it and we can ship it to you in all the 31 regions of United Republic of Tanzania. So you just have to buy it, and then you have to pay the shipping cost just for the transport. And then we have again another weapons, which we call the weapons number 3. Weapons number 2 is a reference books that are called the Pure Mathematics 1, right? We have also Pure Mathematics 2. This is Pure Mathematics 1. And we like just to inform you that you can order also this reference book and we can ship it to you. In advanced mathematics, we have 2 papers. We don't have 3 papers like advanced physics and advanced chemistry. So the first paper is called the Certificate Secondary Education Examination, Advanced Mathematics 1. So this is the questions and answer book, a review book, which comprises questions from 2003 to through 2018. I'll be using this material. These are just the sample books. We have so many books in our library. And also we have Advanced Mathematics 2 Review, Problems and Solutions 2003 through 2018. So actually that you can order these books and we can ship in any regions of United Republic of Tanzania. That is the piece of information that you want. Also you can order the notes for, if you want the written notes, the handwritten or printed, just like it typed in notes, we can also ship to you. You can order, just to go to the descriptions of the video below. Just click the descriptions of the below the video that you are looking right now, where that there is a button written show more. Okay, so you have to click these buttons of show more. So when you click, you will see the link that will send you into this fantastic video for the benefits of your own life. So remember that we are providing this content free of charge, but God has given you an opportunity to also to be a part of by offering your free willing thanksgivings to God through these programs, and you can send it through this telephone number 0759 745 3331. In case you want to do the bank transaction, and then just go to the show more, you'll see the bank accounts, the bank names, and even the bank accounts, the bank names, and even the bank account number, right? The bank name, the bank account name, and the bank account number. So you can offer your free willing thanksgiving to God. Okay, so we have more than 2 departments we have more than 4 departments. One of the departments is called the Departments of Advanced Mathematics. Here we are teaching you 4 subjects: Advanced Mathematics for the Form 5, Advanced Mathematics for the Form 60, Basic Applied Mathematics for 5, and Basic Applied Mathematics for 60. So we are in chapter 4 called Geometry 1. So it means that I would like to do a quick review. We are in the first subtopic that called rectangular Cartesian coordinates. And then this is session 6, problem solving by using the formula of perpendicular distance. These abbreviations. This contains its class this contains is for the Form 5 or class 13 or pre-Form 5 or Form 60 of the following combinations. So in Tanzania we have something called the combinations, where the 3 principles. Okay, so the class, these contents are for the Form 5 or class 13. Also, these contents are relevant for the pre-Form 5, pre-Form 6, Form 60 of the following combinations: PCM, PGM, PMC, and EGM for the Tanzanians. For international students, then I think that this is all about the high school advanced mathematics. Okay, so high school advanced mathematics. So this is advanced physics, advanced chemistry, advanced mathematics, advanced physics, advanced geography, advanced mathematics, advanced physics, advanced mathematics, advanced this is computer science, this is advanced economics, advanced geography, and advanced mathematics. So you see that this is the point, that this is the subject that we're discussing right now. M, then you see M, and then you see M. So M stands for advanced mathematics. So let us continue with today's session. So the quick review of session 5. In session 5, we talked about derivation. So we talked about derivation, and that's the homework that we left you for you. Derivation of 40 of the formula of finding finding perpendicular distance of the point from. Okay, so this is the general formula of finding perpendicular distance of a point from the line. So this is the equation that axu plus by plus c is equal to 0. And then this the point that you call the p, it's x naught comma y naught. And then finally this is the general formula. So whereby we know the values of x naught and y naught will be given. So we know the equations also. And then we know these are the coefficients of this is the coefficient of x, this is the coefficient of y. So we didn't solve any question. We just taught you the derivation, long derivations actually. I think that is one of the longest derivations in advanced mathematics for the Form 5. I'm not sure if there are the other ones, but in case there are the other ones, we'll discuss together. Don't worry that, because I will be with you from the beginnings of this business of advanced mathematics to the end. Remember that these contents are free, but you are invited to offer our code your free willing sense giving for giving or for providing you these contents free of charge, because they are worth. So again, if you refer the session 4, where that we have been solving some problems, we left the homework, which was homework 4, and unfortunately we labeled as example 60, but that is not example 60. If you follow the sequence, this was example 7. So example 7, it was a simple question. So if that's the case, so ladies and gentlemen, today we are going on to solve problems, and then it will be the end of this part of this concept team. So example 8. So the question asking us to do this: find the distance from the point, and this point, it is point A, 3,4, to the given line. This given line is twice x minus y. This is equal to 3. That's the question. The question didn't limit us that we should use the perpendicular distance, but we have a freedom. So you can use the concept I taught you in session 4, or you can use the concept that, or you can use the general formula of the perpendicular distance of of a point from the line. So solution: you can pause the video and try to solve this problem yourself. Then you come back and you check. So you say the first step. We say that we call the general equation at ax plus bx plus by plus c, this is equal to 0, and if another point p, x naught comma y naught, okay, and compare it with the standard equation. So compare it with given information. What will be given there? Okay. So the given means that you'll be given a line which is twice x minus what is y minus 3 is equal to 0. So if we compare, we find that A is equal to 2, B is equal to -1, C is equal to -3. Then you have P x naught is equal to 3, y naught is equal to 4. Right, so that's the point. So we go for the second step. The second step, we say that we call the formula of perpendicular distance. The formula of perpendicular distance from point to A, x naught plus b, y naught plus c. This is square root of a square plus b square. Okay. So the perpendicular distance is equal to, what is the value of a? A, it is 2. What the value of x naught? X naught, it is what? 83. What the value of b? B, it is negative 1. What the value of y naught? Y naught, it is 4. What the value of c is negative 3. It's negative 3. Then this one over square root of a. With the value of a, it is 2 squared. With the value of b, it is negative 1 squared. So the distance is equal to 2 times 3 is 6, then minus 4, then minus 3 over square root of 4 plus 1. Okay? So then we say that perpendicular distance is equal to 6 minus 7 is negative 1, so I also give negative 1 over square root of 5. So this is equal to what? This is equal to 1 over square root of 5. At the perpendicular distance. Distance. We can rationalize the denominator, so you can apply by under root of 5 over under root of 5. We didn't change anything because under 5 and under 5 is equal to 1. And then the distance now is equal to under root of 5 over 5. So therefore, distance from the point A of 3, 4 to 2x. And that's what? And that's y is equal to 3. It is square root of 5 over 5 units. Units. Okay. That's the response. Then we go for example 9. Go for example 9. So find the distance. Find the distance from a point from a point A and point B, and this point B is 0, 0 to the line AX minus BC, AX minus BY plus C, AX minus BY plus C is equal to 0. Okay, that's a question. So you can use the perpendicular distance formula at the simplest one, right? So in this case, we say that solution. So remember that just we follow 2 steps, then we are done. It is simple. First step, say that compare the point what compare point B, which is x naught comma y naught, and line AX plus BY plus C is equal to 0. We sort B to 0, 0, and the line AX minus BY plus C is equal to 0. With, okay? So it's that one. So if you compare, you can find that the value of A is equal to A, the value of B is equal to negative B, the value of C is equal to C, and then we say that the value of x naught, this is equal to 0, the value of y naught is equal to 0. Then we go for the second step. So the second step, we have to recall the perpendicular distance formula, which is absolute. D is equal to absolute of A, x plus by plus C of what? Over square root of what? Of A, B squared. Okay? That's like that one. So the perpendicular distance is equal to what? A is A, x naught, this is x naught, excuse me, this is y naught, x naught it is 0, plus the value of b is negative b, and 0. The value of C is equal to C divided by square root of what? Of A. So the square root of A, which is A square, and the square root of B, which is negative B. So absolute. So distance is equal to what? A times 0 to 0 minus B times 0 to 0. So here we have C. Square root of A squared plus B squared. So simply this is equal to C over square root of A squared plus B squared at the distance. So therefore, say the distance of B, which is 0, 0, to the line AX minus BY plus C is equal to 0 is C over square root of A and square root of B. Just like this. Okay, so the distance of that one's to that one's in that one's units. So that's example 9. Okay. So again, we go for the example 10. find the distance. Find the distance from the point -0, -1 to a line line 2x, y is equal to 2x, y is equal to 2x plus 6. So solution. This question is simple. Just treat it as a quiz. You can try it as a quiz before you change the the concept. So do that quiz. So solution. You just follow 2 steps. The first step, we say that express given equation of the line in standard form. So what are you given? You are given y is equal to twice x plus 6. So y minus twice x minus 6 is equal to the standard form. So we have to compare it with ax plus by plus c is equal to. So a is equal to -2, b is equal to 1, c is equal to -6. That is. So then we have a point where x naught is equal to -3, y naught is equal to -1. And we go for the second step. Second step, have to record the perpendicular distance. This is ax plus by plus c. A squared plus b squared. This is ax naught. This is by naught. So the perpendicular distance is equal to a, 8 is -2, times what? Times x naught, which is -3, plus b is 1. So y naught, which is -1, then plus c. C naught is plus 6. Then we have to find the square root of this stuff. If a, 8 is -2 square, if b is 1 square, then you have distance. Distance is equal to what? Absolute. This is 6. This is -1. This is plus 6 over what? Over the square root. This is 4 plus 1. So this is absolute of what? Of -1 over square root of 5. So the answer is absolute of what? it's 1 over square root of 5. So distance is equal to 1 over square root of 5. So you can rationalize the denominator. Square root of 5, square root of 5. So this is equal to the square root of 5 over 5. Therefore, distance from 20 negative 3 from negative 1 to the line y is equal to x plus 6 is square root of 5 over 5 units. But response. In case you have any question, don't hesitate asking your questions in the comment section. Okay. So then let me change the beat for a moment. Note the general formula of perpendicular distance, of finding perpendicular distance of a point to a line can be used to find the distance between two parallel lines. So this concept can be used to find the distance between two parallel lines. Okay, so why and how is it possible? So let us consider the Cartesian coordinates of the xy plane. This is y-axis, and then here we have x coordinates. This is x-axis. This is 0, 0. Okay, so 0, 0. And suppose that we've been given two parallel lines. First line, then suppose that we have another line here. We have another parallel line. Okay, another parallel line. So you have two parallel lines. So you have this is line 1. This is like 2. So simply you can find the distance between these two lines. Okay, so the distance between these two lines. So this is perpendicular distance. So in case we want to find the distance from this point, suppose that this is point P, so this is $1. We said 1 can be, let's say, ax1 plus b y1 plus c1 is equal to 0. And the equations of this line is ax2 plus b y2 plus c2 is equal to 0. So this is point P. Okay? So point P, you can find any other point. But the most interesting point, we use the x-intercept. Okay, we use the when the x-intercept at the point. So this is x-intercept, for instance, that this is the point we got x-intercept of line 1. So this x-intercept of line 1, you can say that here on P, it is x or what? So you can find the perpendicular distance. So you can find the perpendicular distance. So I can find the perpendicular distance. This is distance B. So while this point P is x-intercept, so you can find this distance D, which is the same with this one. So D is equal to AX naught plus BY naught plus C over square root of A squared plus B squared. This is the formula. So let us see problems. Let us see questions. I believe that you're enjoying the beauty of advanced mathematics for the Form 5. Sure that. Sure that perpendicular. Distance between two parallel lines y is equal to twice x and y is equal to 2x minus 5 and 8.6 units. Okay, so show that the perpendicular distance between two parallel lines, y is equal to 2x plus 3, and y is equal to x minus 5 is 8.6 units. So solution. So we have to show that. Okay, so just see. Now we have two lines and two different lines. So remember that we can choose one line and find the x-intercept, and then also use the second line as a line. Okay. So the first step, find the x-intercept of line y is equal to twice x plus 3. So the x-intercept, remember that always what we taught you in our level, x-intercept, we get x-intercept y is equal to 0. So we got the equation of 0, we have 2x plus 3. So then we have negative 3 over 2 this will be the next intersection. So we'll be finding the distance from the point. So point right now P, which is x intercept, which is negative 0 over 2. Negative 3 over 2 to not from the point. So this is the point. Okay, so the second step we have to express. You have to express it. You have to express it. You have to express y raised x minus what? Minus 5 in the standard or in the general form. The general form, which is ax plus b y plus c is equal to 0. So this is y minus what? Twice x, then plus what? 5 is equal to 0. Y minus 2x plus 5 is equal to what? Equal to 0. Okay. So if that's the case, we say that, okay, fine. So this is the case. So you say we have to compare. So suppose that this is question 1. So let us compare question 1 with this is standard expression. And the standard expression is what? by plus ax plus c is equal to 0. So from that fact, you find b is equal to 1, a is equal to negative 2, c is equal to 5. Y x naught is equal to what? Is equal to negative 3 over 2, and y naught right now is equal to 0. So you go for the third step. The steady state, it's a steady state, we have to select the call the general formula. The general formula of perpendicular distance. General formula of perpendicular distance from a point to a line. Distance from a point to a line. Okay, so if that's the case, we say that the distance is equal to absolute of a x naught b y naught plus c. Square root of a squared plus b squared. The distance 8 is what? 8 is negative 2, comma x naught, which is negative 3 over 2, plus b is 1 and 0, plus c is 5 over square root of a squared. A squared is negative 2 square plus what? 8 is 1 square. So these two and these two cancel. So this one is equal to what? This is equal to absolute of positive 3 plus 0 plus 5 over square root of what? 4 or 5. Square root of 5. So the perpendicular distance, this is equal to absolute of what? Of 8 over square root of 5. That's the distance between the two parallel lines. Okay, so that's the distance, so I can find its value. This is 8 over square root of 5. So use your scientific calculator just to do the computations to find the square root of 5. So you find the square root of 5. Answer is 2.22, so you take 8 over the response. Answer is 3.577. If we estimate, the answer is 3.6 in one decimal place. So here we say that hence shown that the distance between the two parallel, the perpendicular distance is shown that the perpendicular distance between two parallel lines is 3.6 units. And the response. So you see, this is simple like that. Okay? So ladies and gentlemen, before I end this session, let me give you the homework 6. And this will be example 12, where we have questions Roman A and Roman B. Find the distance. Just to test yourself, make sure to submit your homework in the comment section. Don't forget to subscribe for notifications of the future session. Find the distance from the point C, and this point C it is A, B, okay, to a given line, to a line that's called it, to a line y is equal mx plus. Find the distance from that point to another. That's Roman A. Can be find the distance between two parallel lines. Y is equal to 2x plus y. X plus y is equal to 4. And another line is what? 4x plus 2y and this is equal to 4. This is equal to 2. Okay, so make sure to do this homework and submit your homework in the comment section below here of this video. Okay. So, ladies and gentlemen, this is the end of session 6 of Coordinate Geometry 1. I thank God who have created me in His own image and likeness. I thank God who have been with me, who have prepared me and even given me opportunity to teach you. And I thank God who have given you a chance and opportunity to learn the beauty of advanced mathematics with me. So I would like to invite you in the next sessions, which will be session 7 of Coordinate Geometry 1, where now I'll be teaching you the new concept, not about the perpendicular distance. Possibly we can have, maybe can solve one questions from the review or from the Advanced Certificate Secondary Education Examination Advanced Mathematics 1. But otherwise, keep in touch, enjoy the beauty of advanced mathematics. Subscribe, remember to subscribe, share this content with other students, ask a question in the comment section, and get prepared for the next sessions and for the new concepts of the coordinate geometry. And we are about, I think that after a few sessions we'll be finishing the first subtopic of rectangular Cartesian coordinates. So I would like just to ask you that in case you feel from your heart you want to offer God your free will in thanksgiving, you may send it through that telephone number 0759745331. And again, you can, in case you want to do bank transaction, you can just go to the descriptions, show more patterns, and then you will see the information about the bank transactions. Okay, so I'll be praying for you, and I ask you also to pray for me, and may God keep you. And until we meet in the next session, you have to concentrate. Make sure that you do the homework 6 before we meet in the next session, so session 7. In case you find any troubles or any challenges through this process of learning, please don't hesitate to ask questions in the comment section. So may God bless you. This is Olenjolai from Tanzania.